Welcome back. This is video 2 of 2 on the topic of Earth moving beneath my feet. So in the first video, you saw that the Earth moved beneath my feet about 5 or 6 feet during the time that I was in the air. All right, so I jumped up and I was in the air for about 1.0 seconds. When I landed, I was about 5 or 6 feet in a slightly different location. And I explained it was due to the Earth rotating beneath my feet. You didn't believe that, did you? Did you actually go out and try it? Okay. So that's really not the way it works. And again, if you don't believe me, go out and try it. If you jump up, no matter how long you're in the air for, when you come down, you're going to be in the same spot, even though the Earth is rotating. Now, why is that? Well, that comes from Newton's first law. An object will remain in motion unless some external force is exerted upon it. Okay, so you are also moving at the same rate the Earth is moving. You are rotating at 1 revolution per day. So when you jump up, you continue to rotate right above the spot where you jumped. Okay, so when you land, you'll land in the same location. Another way to show this is next time you go to an amusement park, get on the carousel and jump up. When you land, you'll be in the same location of where you started. Now, if you can remain in the air long enough, you are at motion relative to the Earth, so you'll experience some drag force, so you would land in a slightly different location. But on Earth, when you jump up, the air is also moving with you, so you're experiencing no drag. The velocity of you and the air and the Earth are all the same. But the interesting question is, if I did jump up, and it was a fact that the Earth did move beneath my feet, how far would I land from where I jumped up? Okay, so I was telling you the 5 feet in the video, right? So let's estimate how many feet it really would be. It's a pretty easy calculation, actually. If I know the radius of the Earth, and I know my angular displacement over 1 second, my hang time, then I can compute this distance. Okay? All right, so the first thing I need to do is I need to get this angular displacement, and that's equal to the angular velocity times my hang time. Well, the angular velocity of the Earth is, again, 1 revolution per day, but in terms of radians per second, that's 7.27 times 10 to the minus 5th radians per second. If I multiply that by 1 second, I get this angular displacement. So this times 1 is just going to be 7.27 times 10 to the minus 5th radians. Okay? Now, if I multiply that by the radius of the Earth, I will get the actual distance that the Earth rotates beneath my feet when I land. So multiplying 6.3 times 10 to the 6th times 7.27 times 10 to the minus 5th radians gives me 458 meters. Okay? In feet, that's 1,500 feet. So again, if truly when I jumped up, I landed in a different place as the Earth rotated beneath my feet, I would land 1,500 feet in a different location. That's about 5 football fields. So that would be pretty cool. But that's really not the way it works. Thanks for watching.